Okay, yeah, hi students, very good evening everyone. Welcome back to Home Institute and welcome to the series where we are learning the concepts through previous year questions. Yes, many times previous year questions itself can teach you and help you understand particular concepts. So as you know, we have been taking linear algebra, and prior to it I have taken I have taken the videos on the rank of the matrix, linear system of equation, both homogeneous and non-homogeneous. Okay, and now we are taking eigenvalues and eigenvector. Right? Very good evening, everyone. Come on, everybody, quickly share the session and yes, update all your friends that the session is now live. Good evening, Bhanu Prakash. No, Harshraj, it's not that important. It's not important actually. Okay. So yeah, let's get started then. Okay, with eigenvalues and eigenvectors. Okay, so since it is through PYQs, okay, here is the first PYQ. GATE 2017 EE 2 marks question. GATE 17 EE 2 marks question. Let's have a look into it. Okay, let's have a look into it. What are the eigenvalues of this matrix? What are the eigenvalues of the matrix? 0, 1, 0, 0, 0, 1, 0, minus 3, minus 4. Come on. Okay, so now see, before I tell you how to solve it, okay, because it's a PYQ, MCQ with 4 options, can you just quickly nullify the options and say, before you start solving, okay, because when you talk about the eigenvalues, okay, we all know that eigenvalue are mathematically defined as roots of characteristic equation. Okay, the roots of characteristic equation, okay, I'll keep calling it as CE in short, okay. But majorly, many of the questions are solvable only by the property. Okay, what is a characteristic equation in general? Modulus of A minus lambda I equal to 0. Modulus of A minus lambda I equal to 0. But if it is a 3 cross 3 matrix, now most common questions, if it is directly finding eigenvalue, the most common question will be 2 cross 2 or 3 cross 3. 2 cross 2 or 3 cross 3. Okay, this question is on 3 cross 3. I will tell you, we don't have to solve it. It's a free 2 marks question for you. It's a free 2 marks question for you. Okay, but what is a 3 cross 3 characteristic equation? So since 2 cross 2 and 3 cross 3 are most common, okay, let us take the direct characteristic equation. You take it. Okay, so Bhanu says option A. And Viraya also says option number A, I guess, right? Correct. So 3 cross 3 characteristic equation you can write down as lambda cube minus beta 1. This is a very important shortcut. Okay. Later on when I take you towards Cayley-Hamilton theorem, then also all this direct characteristic equation shortcut will help you. Okay. Lambda cube minus beta 1 lambda square. Okay. Plus beta 2 lambda minus beta 3 equal to the 0. Okay. Equal to the 0. No, Harsh, you cannot convert this to the upper triangular matrix. That is applicable for rank, but not for eigenvalue, because converting a matrix, okay, will not change the determinant, but will change the matrix. So, Harsh, that is not allowed. Okay, different matrix, different eigenvalues will come. Okay, so now you see here, what is the value of beta 1? Beta 1 is known as the trace of the matrix. Beta 1 is known as the trace of the matrix. Then, beta 2. Beta 2 is known as sum of minors of the diagonal elements. Sum of the minors of the diagonal elements. Sum of the minors of the diagonal elements. Okay. And what is beta 3 known as? Beta 3 known as the determinant of the matrix. Beta 3 is known as the determinant of the matrix. Rajinder also says option number A. Beta 3 known as the determinant of the matrix. Correct. So now have a look into it. What is the trace? Okay, what is the trace? Let me just write down the matrix again. I'll just write down the matrix here only. Okay, so what is the matrix? 0, 1, 0, 0, 0, 1, and 0, minus 3, minus 4. Okay, so what is the trace of the matrix? Trace means sum of diagonal elements. So that is 0 and minus 4. Okay, which makes it minus 4. Okay, which makes it minus 4. Okay, what is beta 2? Okay, sum of the minors of diagonal elements. Sum of the minors of the diagonal elements. Sum of the minors of the diagonal element. Now, okay, what is the sum of the minors of the diagonal element? See here, this is the first diagonal element. Okay, deleting the row and column. What is left? 0 minus 3. Okay, I'll directly write down this 0 minus minus becomes plus 3. Then second diagonal element, delete the row and column. Okay, 0 minus 0. Okay, 0 minus 0. Okay, and plus this is the third diagonal element, deleting the row and column. This is also 0. This minor is also turning out to be 0. So net value is 3. Net value is 3. Okay, then coming to beta 3. Okay, as I have just written, beta 3 means the determinant of the matrix A. Okay, so what is the determinant here? Okay, determinant here, just expanding about the first row, only the central element minus 1. Okay, that too 0 minus 0. Okay, the determinant of the matrix is 0. Actually, entire column is 0. The determinant is anyways 0. What is there in this? Correct. The determinant is anyways 0. Correct. Good evening, Dharun. Good evening, Asha. Right. Correct. Okay, so this is what is beta 3, the determinant of the matrix. All the three values are here. Now what is there in the characteristic equation? Okay, lambda cube minus beta 1 lambda square. Beta 1 is minus 4, so it becomes plus 4 lambda square. Plus beta 2 lambda. Beta 2 is 3. Beta 2 here is 3, so plus 3 lambda. That's it. There is no beta 3. Okay, this is equal to 0. Okay, so lambda outside, then you have lambda square plus 4 lambda plus 3, which is also factorizable. So lambda plus 1, lambda plus 3 equal to 0. Okay, so what is the value of lambda? 0, minus 1, minus 3. Okay, 0, minus 1, minus 3. 0, minus 1, minus 3. Correct. This is the answer. Okay. Rashmi Rekha, good evening. Okay, so this is the answer. 0, minus 1, minus 3. Option number A. Now see, just to tell you the official method, I have done this calculation. Okay, what is the direct answer here? What is the direct answer? You actually don't need this. Okay, how you are going to solve this question? Direct. Okay, direct. Okay, the sum of eigenvalues, suppose lambda is always equal to the trace of the matrix. See, two most powerful properties. Okay, so one by one, okay, I will keep introducing the properties. Okay, the first two most important properties with respect to eigenvalues and eigenvectors, that the sum of eigenvalues, the sum of lambda is always equal to the trace of the matrix, and product of eigenvalues is always equal to determinant of the matrix. Okay, so actually this question requires nothing if you know this direct property. Sum of lambdas is equal to trace, and what is the trace here? Okay, 0, 0 and minus 4. Okay, the sum of eigenvalue should also be minus 4. Okay, this is minus 5, this is plus 4, this is plus 5. Only option number A. It is a visual question. See, even to do the sum, I am writing the sum because I have to explain you and give you the solution. Okay, but you know, it's an oral question for 2 marks. GATE 2017, doubly 2 marks, oral question almost. And many instances you will find in the exam where sum of eigenvalue or product of eigenvalue is going to save your time. Okay, so the two most powerful properties. Okay, the sum and the trace. The sum and the product of eigenvalues. Okay. Okay, now taking you towards old question, GATE 2009 EC 2 marks question. Again, see, again look into this 2 marks question. Okay, now I will tell you two different methods. The previous question, okay, this is what is the direct method, and this is the method number 2. Okay, this is the method number 2 where you have solved by the forming the characteristic equation, but it is not required in many of the cases. Okay, now here in this, again, what is the method number 1? Method number 1 is the trace method. Sum of lambdas is equal to trace. What is the trace of the matrix? Okay, minus 1 plus 3. Minus 1, another minus 1 and plus 3, and this is equal to 1. This is equal to 1. This is equal to 1. Correct? Okay. Now, in which option the sum of eigenvalue? If you add here, 4j will be left. If you add here, up 5j will be left. If you add here also up plus j left. Okay, here, if you look into it, 3j minus 3j cancel. Then 3 minus 1 minus 1. Yes. Okay, option number D. Only option number D will have the sum of lambdas is equal to the trace. That's it. Option number D, finish. Okay. Right. Option number D, correct. Done. How simple. But here I will tell you one more simple method where even this is also very simple, only manual calculation, oral calculation, but here another method where you don't even have to calculate sum. See, look into the type of matrix. Okay, can I call it as real matrix? See dear, what is a real matrix? Real matrix is one in which all elements are real entries. A real matrix is one in which all the entries of the matrix are real entries. All entries are real entries, correct? All entries are real entries. Okay, so this is definitely a real matrix. This is definitely a real matrix. Okay. Now, if it is a real matrix, okay, if it is a real matrix, complex eigenvalue, if there is a complex eigenvalue, okay, it will always occur in the conjugate pair. I'll take you towards the property. Okay. So two properties I've told you, this is the third one for a real matrix. If alpha plus I beta is an eigenvalue, alpha minus I beta will also be an eigenvalue. That means if there is a complex eigenvalue, it will occur in the conjugate pair. If there is a complex eigenvalue, it will be occurring in the conjugate pair. It will not occur alone. Okay, this is for real matrix. For complex matrix, above property does not hold. Okay, it is especially for real matrix. So have a look into it. Real matrix. Okay, so I'll write down the method number 2 here only. Okay, so alpha plus minus I beta. Okay, eigenvalue alpha plus minus I beta property. Okay, so then also you can directly say only option number D, because here you see minus 6 plus 5j alone. Minus 6 plus 5j alone, not allowed. Okay, here 3 plus 5j alone, 6 minus j alone, complex number not allowed. Here 3 plus j, 3 minus j, okay, but 5 plus j alone not allowed. Any single complex number alone not allowed. It has to occur in the conjugate pair. So option number D again. Okay, option number D again. Simple. Okay, this is a third and a very useful property again. Now see, two eigenvalues of a 3 cross 3 real matrix are given to you. What is the determinant of the matrix P? GATE 2016 CS 1 mark question. GATE 2016 CS 1 mark question. We will come to it. We'll come to that property also, Harshraj. Okay, what are the eigenvalues of A square? Okay. Yeah. The eigenvalues of a 3 cross 3 real matrix are 2 plus under root minus 1 and 3. What is the determinant of P? What is the determinant of P? Yeah, let's do it. What is the determinant of P? Now, because see, real matrix, so again alpha plus minus I beta property. So what are the eigenvalues given? Okay, 3 cross 3 means 3 eigenvalues have to be there. Okay, what is given is 2 plus under root minus 1, that is 2 plus I, and 3, and not given. The third is not given. Okay, the third is not given. So what can I do here? What is this third one? It has to be 2 minus I. It has to be 2 minus I because of conjugate pair. Okay, alpha plus I beta, alpha minus I beta. 2 plus I means 2 minus I. Also has to be there. With 2 plus I, 2 minus I also has to be there. Correct? Okay, now what is the determinant of the matrix P? Determinant of P, okay, is related to product of lambdas, the second property. Product of lambda, so that is 2 plus I. Next is 2 minus I into 3. So this becomes 2 square 4 minus I square. So minus minus plus 1. Okay, I square is minus 1. So 5 into 3, 15 is the correct answer. 15. Yes, Bhanu Prakash, correct. 15 is the very correct answer. Okay, 15 is the very correct answer. Okay, next. If the sum and product of the eigenvalues, if the sum and product of the eigenvalues of a 2 cross 2 real matrix are 4 and minus 1, then what is modulus of P? Okay, there is some number P here. Okay, again 2 marks question only on the sum and product. The sum and product of eigenvalues. Okay, so what is the sum of lambdas? Okay, should be also equal to the trace. So what is the sum of eigenvalue given? 4. And what is the trace of the matrix? 3 plus Q. Okay, so Q equal to 1. Okay, what about product of lambdas? What about products of lambda? Product of lambda is the determinant of the matrix. Okay, so the product of lambda will be, sorry, here I have taken, Correct only. Sum of eigenvalue was given 4 directly. Now product is given as -1. Correct only. Product is given as -1 and this is equal to determinant of the matrix. Determinant is 3q minus p square. Okay, so what is the value of q? 1. Okay, so hence we get p square equal to 3 plus 1, 4. So what is the value of p? Under root of 4, we'll write plus or minus 2. Okay, determinant of p equal to 2. The determinant means, sorry, magnitude of p is equal to 2. Simple question. Simple question for 2 marks. Answer is 2. The absolute value of p, the modulus of p is equal to 2. Correct? Okay. Then let's move towards the next question. Next question. Here it is. Now see, I will give you this one question as homework. Okay, this is homework number 1 for today, and what you have to do, you have to solve it and reply the answer in the comment box later after the video get over. Let's continue with next question. Why I'm giving as homework? Because this question is actually not on eigenvalue. The question says eigenvalue. The question says what is the absolute value of the product of eigenvalues. Okay. It's a 4 cross 4 matrix. It's not that you have to, spend time in calculating the eigenvalues of 4 cross 4 matrix. It will be very, very lengthy if you try calculating the eigenvalues of 4 cross 4 matrix. Okay, but you should realize that the value, absolute value of product of eigenvalue. So the product of eigenvalue is equal to what? Okay, answer is equal to what? Answer you have to calculate as the determinant of the given matrix. Okay, is simply equal to the det R. So it is actually a determinant question. So I'm giving you as homework. Okay. You can calculate determinant, some basic row operations you can apply. Okay, like this is all 1, 1, 1. You can convert to 0, R2 minus R1, R3 minus R1, R4 minus R1, or whatever you want to do. Okay, determinant you can calculate, I guess. Okay, so this is the homework number 1 for today. The question uses the language of eigenvalue, but it is just a determinant question. Okay, it's not a pure eigenvalue question, but that knowledge has to be there. Product of eigenvalue is det of the matrix, determinant of R. Next one. Consider the matrix 5 minus 1, 4, 1. Which of the following statement is true for the eigenvalues and eigenvectors of this matrix? Eigenvalues and eigenvectors of this matrix. Come on. Now, it's a 2 cross 2 matrix. Now, as I told you, now let's learn again something new. Let's learn the new thing here. What is the characteristic equation in general? We have discussed that characteristic equation is given by modulus of A minus lambda equal to 0. But for a 2 cross 2 matrix, what is the characteristic equation? I told you, either 3 cross 3 or 2 cross 2. This is what directly you will use. Okay, in eigenvalues also, and next when I take Cayley-Hamilton, there also, the characteristic equation, direct writing of characteristic equation is going to be important. Okay, consider this as an important equation for you. Okay, the 2 cross 2 characteristic equation will be lambda square minus trace into lambda plus determinant equal to 0. Okay, so dear, what is the matrix given here? Simple, 5 minus 1 and 4 and 1. 5 minus 1, 4 and 1. Okay, so what is the characteristic equation? Now you see directly, lambda square minus trace. Now what is the trace? Sum of the diagonal numbers, 5 plus 1 plus determinant. Okay, so that makes it 5 minus plus 4 equal to 0. Okay, so you have lambda square minus of 6 lambda plus of 9 equal to 0. Lambda square minus 6 lambda plus 9 equal to 0, which is also, I guess, lambda minus 3 whole square identity. A square plus B square minus 2AB. Okay, this is equal to 0. So what is the lambda? 3 and 3. What is the value of lambda? 3 and 3. What is the value of lambda? Is 3 and 3. Okay. So, which of the following statement is true? Gate 17 civil 2 marks question. Okay, eigenvalue 3 has a multiplicity of 2, correct? Eigenvalue 3 has a multiplicity of 2. That multiplicity means how many times it appears? It appears 2 times. Okay, eigenvalue 3 has a multiplicity of 2. Okay, option number A, B, C all speaking about the same fact. Eigenvalues are 3 and minus 3. No. Okay, so D is not correct. But then, what is the correct option in A, B, C? How many independent eigenvectors? Okay, and how many independent eigenvectors? How many independent eigenvectors? Okay, have a look into it. Eigenvalue has a multiplicity of 2. Okay, and only one independent eigenvector exists, 2 independent eigenvector exist, or no independent eigenvector will exist. Have a look into this. Okay, the next property directly. Okay, I'll tell you the number of, next property, number 4. Okay, the number of linearly independent eigenvectors of a matrix, the number of linearly independent eigenvectors of a matrix is equal to number of distinct eigenvalues. Number of distinct, how many are distinct, unique eigenvalues, non-repeated eigenvalues. Okay, so here you see how many distinct eigenvalue? Only one distinct eigenvalue. 3 and 3. The other one is repeated, but distinct, only one distinct eigenvalue. Okay, so how many independent eigenvector? One independent eigenvector. So I will mark option number A. Eigenvalue 3 has a multiplicity of 2 and only one independent eigenvector. And only one independent eigenvector. Correct? And only one independent eigenvector. This is what it is. Option number A. Option number A. Next question. Number of distinct eigenvalues of the given matrix. GATE 2019 EC 1 mark. Direct question. It's a visual question actually. Okay, it's a visual question only actually. The number of distinct eigenvalues of this matrix are how much? Okay, what property can be applied here? See. Yeah. Okay, so number of distinct eigenvalues. Let's solve it. What are the distinct eigenvalues of the matrix? Okay, what are the distinct eigenvalues of the matrix? Okay. No, not directly, Harshraj. Yes. Rashmi Rekha, correct. It's a upper triangular matrix. Yes, that is what I was waiting for. You see here. You look into this matrix. Okay, it's a upper triangular matrix. Now, dear, whenever there is a triangular matrix, you don't have to calculate the eigenvalues. Okay, why? Because eigenvalues, okay, here eigenvalues are simply equal to diagonal elements. So if I ask you, what are the eigenvalues of the matrix? So 2, 1, 3 and 2. This is repeated. How many distinct? 3. Okay, the fourth one is repeated. How many distinct? 3. Finish. So that is what is the next property for you. Number 5. Keep marking. I'm going with the numbering as well. Okay, for a triangular matrix, eigenvalues are equal to diagonal elements. Okay, like this example I've taken, it's upper triangular, upper or lower, anything. Upper triangular or lower triangular. This is valid for both. Okay, the eigenvalues are just the diagonal numbers a11, a22, a33. Finish. Okay, so this is the property number 5 for you. Okay. Next, number of linearly independent eigenvectors of this matrix. The number of linearly independent eigenvectors of this matrix. Have a look into it. Number of linearly independent eigenvectors of the matrix. Okay, 2, 1, 0, 0, 2, 0, 0, 0, 3. So see, what I just covered is number of linearly independent eigenvectors is equal to number of distinct eigenvalues. Okay, the property number 4. This should be equal to number of distinct eigenvalues. And what are distinct eigenvalues? Now see again, upper triangular matrix. What are the lambdas? 2, 2, 3. Because if it is a triangular matrix, directly you can write down the diagonal numbers as the answer. So 2, 2, 3. How many are distinct? Again, one is repeated. Okay, how many are distinct? 2. The answer is 2. Simple. So many properties. See, this is a 2-mark question. Look into this. A 2-mark question. Many times this property will enable you, will help you save a lot of time. Okay. Will help you save a lot of time. So be very clear about all the properties. Okay, this is what till 5th we are done now. Okay, come here. No, Harsh, what you are telling is separate. That is GM. I'm asking the total independent eigenvectors. Okay, now let's come to a eigenvector question itself. Okay, now let us come to a eigenvector question itself. Okay, what is the value of P such that the vector 1, 2, 3 is an eigenvector of the matrix? Is an eigenvector of the matrix 4, 1, 2, P 2, 1, 14 minus 4 and 10. Tell me the value of P such that the vector is an eigenvector. Okay, it's a simple 1 mark question, gate 15 EC 1 mark. Now, whenever a vector is an eigenvector of the matrix, okay, it will always satisfy. You don't have to solve. It will take a lot of time if you have to actually calculate eigenvectors of 3 cross 3 matrix, but it will always satisfy Ax equal to lambda x. Okay. It will always equal to Ax equal to lambda x. Yes, correct, Harsh. That is what we have to do. Okay, an eigenvector is one for which Ax equal to lambda x. A into x is equal to A into x is always proportional to x. Like 3x, 4x, 10x. It can be any number proportional to x. It can be any number proportional to x. Okay. How to find distinct? Dharun, you see here, na? These two are distinct. This is repeated. Distinct means different. Okay. So how many are different? One different, two different. This is not different. Na? This is repeated. So that repeated one you have to neglect. Okay. Correct. So if I just start satisfying Ax equal to lambda x, what do I get? 4, 1, 2. P, 2, 1. 14 minus 4 and 10 into x, that is 1, 2, 3 into 1, 2, 3 is equal to lambda into x. Okay, x is the given eigenvector. Okay, Ax equal to lambda x. That's it. This is what we have to satisfy. Now, when I multiply left side, okay, 4 plus 2 plus 6 becomes how much? Okay, so left side is 4 plus 2 plus 6. Okay, let me write down the numbers. Then what it is? P plus 4 plus 3. Next is 14 minus 8 plus 30. Okay, this is equal to right side. If I multiply lambda inside, to lambda and 2 lambda and 3 lambda. Okay, so now the left side is 12, then P plus 7, and then 14 minus 8 will be 6 plus 30. So 36 is equal to lambda, 2 lambda, 3 lambda. What is the corresponding eigenvalue also is obtained now. Okay, so what is lambda? From the first element you can say lambda is 12. Okay, and then from the second element P plus 7 is 2 lambda, which is 24. So what is the P? 17. What is the P? Is 17. What is the value of P? Is 17. 1717. Okay, 1717. Correct. Naresh, just recheck the calculation. It is turning out to be 17. Okay, next question. Okay, next question. Gate 2024. Now see, from this particular pattern, eigenvector, identifying the eigenvector, commonly in the recent years, MSQ questions have been framed easily. Okay, MSQ questions have been framed easily. Okay, so look into this and answer. Look into this one as answer. Okay, what is there in this question? Okay, given the matrix 1k 2 1 where k is a positive real number, which of the following is or are the eigenvectors of the matrix? Which of the following is or are the eigenvectors of the matrix? Okay, so see, again, whatever is the eigenvector, it has to satisfy again what? Eigenvector. So again it has to satisfy Ax equal to lambda x. Ax equal to lambda x. Ax equal to lambda x. Okay, so yeah, let's do it. Ax equal to lambda x. So see, what is there in this question? Okay, so if I take a into x, Okay, so I'll take 1, k, 2, 1. Okay, and what is x? I have to verify the option. Let's go with the option. Okay, what is the option number A? It is root over 2k, 1. Okay, so now if I multiply first row, root 2k plus k, and second 2 root 2k and plus 1. Now, is it any multiple of this given vector? Okay, so that is what you have to first multiply ax. Okay, so 1k 2 1 multiplied by this vector root 2k and minus 1. Sorry, the option number A is with minus 1. Okay, so I have to change the values here as well. What is that first option? Okay, root 2k, root over 2k minus k. Okay, then 2 root 2k minus 1. Minus 1. Okay. Okay, so let's check it out now. I don't think this is going to satisfy lambda into x, because lambda into x means minus 1 has to be restored. Okay, so if I anyhow want to take minus 1 here, I will have to take what common? I will have to take, okay, 1 minus 2 root 2k. I'll take this outside. Okay, and then minus 1 is left. Okay, minus 1 is left. Okay. But if I have to take 1 minus 2 root 2k, will I get it from here as well? Okay, the above one, okay, above one actually root k common. Above one only root k common, you can write root 2 minus root k. No, I don't think it makes any sense. Okay, 1 minus 2 root 2k. And here I want root over 2k. No, okay, no problem. I'll take root 2k only as common. Correct. So if I try taking root 2k common here, sorry, I'll show you in a reverse manner. So I have taken minus 1 common here, and minus if I take common, so I get 1 minus 2 root 2k. Okay, then if I take root 2k common here, okay, if I take root 2k common here, 1 minus now k divided by root over 2k. Okay, so this is how much? Okay, k divided by root 2k. Okay, so no, it's not going to match. No. These two are not equal. If these two are equal, I'll take common, because this will be root over k by 2. No. Okay, so anyhow, this is not matching. Okay, anyhow, this is of no use. This is not equal to lambda x. Got it? A option not correct. Okay, A option not take. Okay, right. A option not take. Yeah. This is what, just if you want, you can take value of k, no problem. Okay, that is also okay. Okay, where k is a positive real number, take any positive real value. Okay, but okay, option number B, since I have started, I will go by the generalization only. Okay, so 1k, because of the root, okay, it's taken a little bit more time. Okay, next one is 1 and root over 2 by k, root over 2 by k. Okay, root over 2 by k. Now see, even option number C, these two will be combined. Okay, whether I try A or C, I don't think C is also going to work. If I take minus or plus 1, okay, what is the difference? It will be plus and it will be plus here. Okay, then I don't need to take, anything common here. If I take minus, or next case will be plus only. Okay, with the plus also, it's not going to satisfy lambda x. No. Okay, if I take plus, I need to be taken as 2 root 2k minus 1, root 2k outside. Yeah, no. Okay, so with plus 1 also, okay, not A or C, both are not correct. I'm now trying B. Okay, I'm now trying B, 1 and root over 2 by k. Okay, so now if I solve it, 1 and then plus k by 2 root 2k. Okay, so it will be root 2k, and then next 2 plus root over 2 by k. What I want root over 2 by k outside, and on numerator I want 1 only. Okay, so let it be 1 plus root over 2k only. Then I'll take root over 2 by k common here. So this becomes 1. And if you take root over 2 by k common, okay, so you'll have to divide 2 by, I will divide here only 2 by root over 2 by k. Now I think the things have matched. Okay, now this is equal to how much? 1 plus root 2k, and then root over 2 by k, 1 plus k goes above, 2 by root 2 will be root 2. Yeah. So now I am able to take 1 plus root 2k common. Okay. So now this is equal to 1 plus root over 2k common, 1 over root 2k common, 1 and root 2 by k. Okay. So yes, I have been able to obtain ax equal to lambda x. I get the same value of x. Okay, I get the same value of x. What is the lambda obtained? 1 plus root 2k. 1 plus root 2k. 1 plus root 2k. Correct? 1 plus root 2k. Okay. C is still not coming, na? Is C coming? I think I just randomly tried. No problem. I'll retry it. C, I don't think is still going to come. Just let me check it for a second. Okay. So what is there in the C option? Okay. See, what is there in the C option? If you want me to try it separately. Okay. AX, some of you suggesting C, 1k to 1 multiplied by root 2k and plus 1. If I multiplied it, okay, so I'm getting 1. Sorry. I'm getting root over 2k and plus k. And next I'm going to get 2 root 2k plus 1. Okay, and I want only 1 here. Only from numerator, let me take root over 2k common. Okay, 1 plus k by root 2k. No, that's not coming. That's what I told you. K by root 2k. Okay, so that's going to cancel and only k by root 2 will be there. Here, oh, you only want 1. No. No, it's not going to come up anyhow. Okay, I hope my calculations are correct. No, C is not correct. I told you earlier only. Okay, I told you earlier only. C is not correct. Okay. C is not correct. Okay. C is not correct. Then D option, I think there is a typing error here. Okay, what is there in the D option? Okay, what is there in the D option? 1 and root 2 by k, and this is, I guess, minus 1. I think there's a typo error coming up here. Okay, B and D actually both will be correct. I have given you enough hint to solve. Rest you solve. D also similar. Okay, with that number of root over 2 by k, only minus 1 is the difference. This will also satisfy AX equal to lambda x. Okay, similarly, D will also satisfy. Okay, that I leave to you. So what I'm telling you, from this eigenvalue and eigenvector, na, MSQ questions they have framed. Okay, in the recent years. Okay, so because a matrix can have multiple eigenvectors. So this one will be your homework number 2 for the day. This one is your homework number 2 for the day. Which of the following is or are the eigenvectors of the matrix given below? Eigenvectors of the matrix given below. Okay. So again, you have to satisfy 4 cross 4, so little time taking, little calculative. Okay, little, see, it's not going to be highly calculative also, because see, the options have some zeros, that if those zeros will simplify the calculation, but the approach is same. The approach is same. Eigenvector based question, AX equal to lambda x. Okay, 2022 CS 2 marks question. Okay, yeah, next question. Now, next question. Have a look into this next question. Important one. Now, next very important property is going to come up. Sorry, coming back here. So the eigenvalue of a 2 cross 2 matrix are 1 and -2 with the eigenvector x1 and x2. Okay, then the eigenvalue and eigenvectors of this matrix, okay, which is a function of a square minus 3a plus 4i. A square minus 3a plus 4i will be how much? What will be the eigenvalue? What will be the eigenvector? Property number 6, and a very important property. Now a very important property. What is a very important property here? Okay, have a look into it. Okay, a matrix A has the eigenvalue lambda, eigenvector x. A matrix A has the eigenvalue lambda, eigenvector x. Okay, a matrix A power n will have the eigenvalue lambda power n with the same eigenvector. The matrix A inverse will have the eigenvalue lambda inverse with the same eigenvector. The matrix A plus I will have the eigenvalue lambda plus 1 with the same eigenvector. K into A, K into lambda. That means any function of A you take, any operation you take on the A, okay, the same operation applied to the eigenvalue. Okay, that is f lambda. Okay, Fa, eigenvalue f lambda. Fa, eigenvalue f lambda. Okay, eigenvector in all these cases remain to be same. Okay. Yeah, only thing is one operation A transpose. Okay, eigenvalue of A and A transpose are same, but eigenvectors you have to find separately. I cannot generalize what is the eigenvector. I don't say x or I don't say 2x, nothing. We have to find separately the eigenvectors if the eigenvectors of A transpose are required. But if eigenvectors of any function of A required, it remains to be same. Eigenvalue is affected. Fa, f lambda. Okay, Fa, f lambda. So what is given in this question? Fa. Okay, so what will be the eigenvalue? Okay, so dear, this is a simple question actually. If A has the eigenvalue, how much? If A has the eigenvalue lambda, okay, then A square minus 3A plus 4I will have what eigenvalue? Lambda square. A square means lambda square. 3 times A, so 3 times lambda. Plus 4I, so plus 4. Lambda square minus 3 lambda plus 4. Lambda square minus 3 lambda plus 4. Okay, now what is the value of lambda? Lambda is 1. Okay, so 1 square minus 3 into 1 plus 4. Okay, so that becomes 5 minus 3, 2. And second one, what is the second lambda? Minus 2. So minus 2 square minus 3 into minus 2 plus 4. Okay, plus 4. So how much this becomes? Okay, this is 4. 4 plus 4, 8, and plus 6, 14. 2 and 14. 2 and 14. But eigenvectors remain to be same, x1 and x2 only. So option number A. Option number A. Eigenvectors remain to be same. Okay. 2 and 14, x1 and x2. Next one. Okay. So this is a very useful property. See the next question onto it. GATE 2022 MSQ 1 mark question. MSQ 1 mark question. What is given? The matrix M is given as 1, 3, 4, 2. It has the eigenvalues 5 and minus 2. See, for a 2 cross 2 matrix, you can easily calculate eigenvalues. But still they have given it. Still they have given it. So they are more interested in property rather than eigenvalue calculation. Okay, they have given that the matrix M has the eigenvalue lambda 5 and minus 2. The matrix Q is formed as M cube minus 4M square minus 2M. What should be the eigenvalue of this? Lambda cube minus 4 lambda square minus 2 lambda. Lambda cube minus 4 lambda square minus 2 lambda. Okay, what will be the lambda here? Tell me. What is going to be the lambda? Now, what is the first lambda? 5. Okay, so this is going to be number 1. Okay, 5 cube minus 4 into 5 square minus 2 into 5. Correct. So this is 125 minus 4 into 25, 100 minus 10. Okay, total answer is 25 minus 10, 15. One of them is 15. Second one, okay, second lambda is minus 2. So minus 2 whole cube minus 4 into minus 2 square minus 2 into minus 2. This becomes minus 8 minus 4, 16 and plus 4. So this is minus 20. 15 and minus 20. MSQ question, 2 options you have to tick mark. Okay, one of them is 15, one of them is minus 20. Direct that property question. This is going to be very important, and I'm showing you some PYQs. Many PYQs are actually based out of this property. Many PYQs have been based out of this property. Correct? Right. Okay. Now let me show you. Okay, how it jumped back here. Sorry. Look into it. GATE 2023 MSQ 2 marks question, direct on the property. Direct on the property. Given the matrix A, which of the following statement is or are true? Okay, eigenvalues of A transpose are same as eigenvalues of A. See, for this matrix also not required. Any matrix they give, but eigenvalue of A and A transpose same. Correct. MSQ question means more than one answer can also be correct. Next. Eigenvalue of A inverse are the reciprocals. Yes. Eigenvalues of A inverse are lambda inverse. That is 1 by lambda. Reciprocal of the eigenvalue of A. Correct. Eigenvectors of A transpose are same as eigenvectors of A. No. No. And next. Eigenvectors of A inverse or any function of A are same as the eigenvectors of A. Correct. A, B, D. 3 options are correct here. Direct tick mark question if you are aware about these properties. A, B, D. These are the 3 options correct here. Okay. Done. Next. Consider the 5 cross 5 matrix. Consider the 5 cross 5 matrix. Right. Okay. 5 cross 5 matrix. 1, 2, 3, 4, 5. 5, 1, 2, 3, 4. 4, 5, 1, 2, 3. 3, 4, 5, 1, 2. 2, 3, 4, 5, 1. It is given that. Now see, it is a 5 cross 5 matrix. See, it is a 5 cross 5 matrix. Calculating all eigenvalues of the 5 cross 5 matrix will be actually lengthy. Right? Okay, will be actually lengthy. So, what we are supposed to do? Okay, the question says that A has only one real eigenvalue. The matrix A has only one real eigenvalue. They are not asking all 5. They have mentioned in data, it has only one real eigenvalue. What is that real eigenvalue? What is that real eigenvalue? Now, if you see the elements of every row are same, they are just rotated 1, 2, 3, 4, 5. Then 5, 1, 2, 3, 4. 4, 5, 1, 2, 3. 3, 4, 5, 1, 2. 2, 3, 4, 5, 1. Okay, this is what it is. This is what it is. Okay. So these are the different elements. Okay, but all elements are same. They are just rotated. So if I talk about sum of the elements of each row, sum of the elements of each row, how much is the sum of the elements of each row? Okay, 1 plus 2 plus 3 plus 4 plus 5 is 15, and that is same. Sum of elements of each row is same. Okay. No need to apply any, and row operation you should not apply. Row operations will change the eigenvalues. It will not change the determinant of matrix. Row operations are only for determinant calculation. Okay. So now next, property number 7. Property number 7. If the sum of the elements of every row or every column is same, if sum of the elements of every row is same, then one of the eigenvalue is always equal to that sum. Okay, here you see the sum of the elements of every row is same, then one of the eigenvalue. So I can say that one of the eigenvalue of the matrix is also equal to that sum, is equal to the 15, and which is already real. Now they have mentioned the matrix has only one real eigenvalue. Okay, so which is that real eigenvalue? One side they say one real eigenvalue, and I am from my side telling that there is one eigenvalue which is 15, automatically real. Okay, so there cannot be any other real eigenvalue as per the data of the question. So what is that real eigenvalue? Option number C, 15. Finish. Option number C, 15. 15. Every possible condition I am taking, every possible property I mean. Okay. Okay, next property. Okay, next, just you should be aware about this property. Okay, the rank of a matrix, relation between rank and eigenvalue. The rank of a matrix is equal to number of non-zero eigenvalues of the matrix. Number of non-zero eigenvalues of the matrix. You can just go to the previous first or second question, you can tally it. Okay, if you want, you can tally it. Okay, the rank is number of non-zero eigenvalue. Only exception to the property is it should not be a diagonal or triangular matrix. This is exception. Okay, except for diagonal and triangular matrix, this is a general property. Rank is number of non-zero eigenvalues. Okay, now next question and the next property. Have a look into this one. Okay, consider the matrix A, 50, 70, 70, 80, whose eigenvectors corresponding to eigenvalues lambda 1 and lambda 2 are x1 and x2. What is x1 transpose x2? GATE 2017 2 marks question. GATE 2017, mechanical 2 marks question. What is the value of x1 transpose x2? Now see here. Okay, see method number 1. First, I'll talk about a direct method. Yeah, tell me. M1 and M2, method 1 and method 2. Okay, so what is the method number 1? Okay, you don't apply any property. You start calculating x1 transpose x2. Okay, x1 transpose x2. x1 is given. Take the transpose of it. That means convert to the row. It becomes 70 and lambda 1 minus 50. And then the x2 is lambda 2 minus 80 and then the 70. Okay, so what is the first one? 70 into lambda 2 minus 80 plus 70. Okay, multiplying the second element, lambda 1 minus 50. But dear, what is lambda 1, lambda 2? Not given, na? Not required also. Not required also. See, this is 70. Okay, lambda 1 plus lambda 2. 70 can be taken common. Okay, then what is this? 70 into 80 yeah, 5600. 70 into 50, 3500. But what is lambda 1 plus lambda 2? Sum of eigenvalues is equal to trace, and trace of the matrix 50 plus 80, 130. Okay, so 70 into 130 minus this is 9100. Okay, 70 into 130 is also 9100. So 9100 minus 9100 is 0. 9100 minus 9100 is 0. Answer is 0. There can be one property associated here. Okay, but this is just, direct calculation also says it is 0. Okay, yeah. Okay, so this is method number 1. Okay, now have a look into the matrix where I will now discuss method number 2. Okay, what is the type of the matrix? 50, 70, 70 and 80. 50, 70, 70 and 80. Okay, 50, 70, 70 and 80. Correct, na? Okay, what is the type of the matrix? Can I call it as a symmetric matrix? See, this is the diagonal element. Okay, this is the diagonal line. Elements above and below the diagonal are same. Elements above and below the diagonal are same. This is a symmetric matrix. This is a symmetric matrix. Okay, but not only symmetric, it is a real symmetric matrix. Okay, this is a real symmetric matrix. This is a real and symmetric matrix. Correct? Real and symmetric matrix. Now, what is the special property for real and symmetric matrix? Okay, the eigenvalues of a real symmetric matrix are always real. Okay, so now next set of properties, eigenvalues of a real symmetric matrix are always real. Okay, so the question is not asking eigenvalue, but yeah, even if you calculate the eigenvalue of it, there will be two eigenvalue, both will be real 100%. Okay, next, eigenvectors corresponding to distinct eigenvalues. Now, this is important. Eigenvectors corresponding to distinct eigenvalues, okay, of a real symmetric matrix will be orthogonal to each other. That means, okay, if lambda 1 not equal to lambda 2, if you have two distinct eigenvalues, their corresponding eigenvectors will be orthogonal. Okay, x1 will be perpendicular to x2. Okay, so that they are dot product x1 transpose x2. This is how we write dot product in the vector form. Okay, x1 transpose x2 will be 0. And that is what actually is there in this question. Okay, Otherwise, if you start solving x1 transpose x2 also is directly also simple only. But if you just apply, okay, the real symmetric matrix concept, given two eigenvalues, lambda 1 and lambda 2, lambda 1 not equal to lambda 2. Okay, so directly we can say that x1 perpendicular to x2. So x1 transpose x2 equal to 0. That is a direct property way of solving this question. Otherwise also the answer is 0. If you solve it also manually, it is going to be 0. Correct. Okay, and then some more properties. See, these properties are important for factual and property question as well. Like especially these two have been asked many times direct as a property. Eigenvalues of a real symmetric matrix, always real. Eigenvalues of a real skew symmetric matrix are either 0 or pure imaginary. These two have been repeatedly discussed directly, indirectly. Then eigenvalues of a Hermitian matrix are also real. Eigenvalues of a skew Hermitian matrix will be 0 or pure imaginary. And eigenvalues of a unitary matrix or a real orthogonal matrix satisfy mod lambda equal to 1. That means all the eigenvalues will have magnitude equal to 1, whether they are real or complex. Okay, so I hope you are aware about Hermitian or unitary skew Hermitian matrix. Okay, that is the thing which is not required to be repeated here. Okay. Some crucial information for all of you. Okay, so GATE 2026 EE, the new offline batch. Yes, you can study now in a very competitive atmosphere with hundreds of students and more important face-to-face in front of the best ECEE faculty team of the country. Okay, the new offline batch, okay, at our Hyderabad center starts August 18 for EE and August 10 for EC. The fee 65,999 is currently priced at 54,999 with some more special discounts as mentioned. Okay, you can contact 95156 for any queries. Okay, and if you want, if you cannot come to Hyderabad for any reason, maybe you are in college right now, for some reason you can't attend the offline sessions and still want the same content, okay, by the same faculty team, you can enroll to the online live course, okay, which is available for GATE 26 and also for GATE 27. 1 year and 2 years, both the modules are available with the fees mentioned. And also, okay, yeah, the current fees is 1999 for 1 year validity, 28,999 for 2 year. But yes, since this is the month of Independence, August, so OM Institute has brought to you the Independence Day special offer. Okay, the Independence Day special offer, which will, wherein you can use the code freedom20, and using this code you can get 20% flat discount on all the OM online courses, live as well as pre-recorded. Yes, and this is going to be applicable till 20th of August. This is going to be applicable till 20th of August. So take the benefit of this. And in case if you're preparing for AE courses, okay, so you can join the new offline batches. Okay, the new online batches at the Hyderabad Center for AE. Okay, starts August 10th. Okay, starts the coming Monday, August 10th. Sorry, the Sunday, August 10th. Okay, that's it for this video. Okay, I'll share you the PDF of today's video in my Telegram. Okay, the PDF is going to be password protected and the password is going to be Eigen based on the today's topic. Everything in small. The password will be Eigen. The password is going to be Eigen. E-I-G-E-N. Okay. You'll get the PDF in the Telegram group, the link mentioned here. Okay. So that's it, dear. Thank you for joining this video for me, with the video with me, and we'll see you in another video. The next video I'm going to take is going to be on Cayley-Hamilton theorem. Yes, Cayley-Hamilton theorem. Okay. Thank you. Stay safe. Take care of yourself.